Hello everybody, this is Professor Lombardo. I just wanted to record a couple extra examples on conditional probability and on the topic of independence and using Bayes' rule. So the next few videos will do exactly that. So for right now I just want to talk about this idea of conditional probability. The main thing to keep in mind with conditional probability is this formula here. So the probability of A given B is equal to the probability of intersection with A and B divided by the probability of B. What's going on here is we're starting out with a larger sample space, let's call it S. Inside of that sample space is the event B and the event A, which in this case I've drawn so that they have an overlap. So the given information that event B has actually occurred changes our sample space from S to the new sample space B. And because of that, we want to ignore all the possibilities that occur outside of B. So now if we're thinking about a probability, sort of the chance of a particular event happening given the chance of anything happening, in our case this would be the probability of the intersection of A and B. And then since our new sample space is B, this is kind of like dividing by the total. So we have probability of A intersection B divided by the probability of B. Closely related to this formula is the following. The probability of B times the conditional probability A given B is equal to the intersection. All we've done in this case is just kind of cross-multiplied in order to get a different formation of really the same conditional probability formula. This is going to be a really important formula to remember as well, and I want to do an example that shows you why this would show up. Basically, the idea is that sometimes the information given to us is in terms of a conditional probability. Let's consider this example. A doctor is studying the relationship between blood pressure and heartbeat abnormalities in her patients. She tests a random sample of patients and notes their blood pressure. So the options here for blood pressure are going to be high, low, or normal blood pressure. The abnormalities are going to be classified as either regular or irregular. All right. So the information given is we have a 14% chance of having high blood pressure, a 22% chance of having low blood pressure, and we know that there's a 15% chance of having an irregular heartbeat. All right. The next two pieces of information are given to us in terms of a conditional probability. And the way to really notify this or visualize this is that the first sentence says, of those with a particular property. So this is essentially telling us, given that we have an irregular heartbeat, 1/3 have high blood pressure. All right, so in our next piece of information, again, we're given a conditional probability. So of those with normal blood pressure, 1/8 of these are considered to have an irregular heartbeat. So what we want to do is record all of this information on the next slide. So it's important to keep in mind that the different types of blood pressure, high, normal, low, and whether you have a regular or irregular heartbeat, these are considered mutually exclusive events. So here's the idea. Here's our entire sample population of people in this study, and we can split them into one of two categories. They either have a regular or irregular heartbeat. So these two things are mutually exclusive. Additionally, we can take the entire population and we can split it into three separate categories. One being that they have high blood pressure, one being that they have normal blood pressure, and one being that they have low blood pressure. All right. So what we want to do, suppose we wanted to know how many people have a regular heartbeat, we could count up these separate intersections, all right, H intersect R, N intersect R, L intersect R, right? And that would tell us information about what's going on with our regular heartbeats. And we can look at the irregular heartbeats as well. So this would be H intersect R prime, this would be N intersect R prime, and this would be L intersect R prime. So each of these intersections H intersect R, this would be mutually exclusive from N intersect R, right? These can't happen at the same time because you either have high blood pressure or you have normal blood pressure. There's no overlap here. Okay, so we're going to think of these H intersect R, N intersect R, L intersect R. These are all mutually exclusive events from the other intersections listed. We're going to keep track of this information using a table. So let's record some information here. We know that the options in terms of regularity for the heartbeat are either you have a regular heartbeat or it's irregular. Checking the previous slide, we know that there's a 15% chance that we have an irregular heartbeat. Now, since we're either we either have an irregular heartbeat or a regular heartbeat, this kind of forces our regular heartbeat to be 85%. We have an 85% chance of having a regular heartbeat. The other options to look for is what type of blood pressure do we have. So we have an H for high, we can use N for normal, and L for low. From the previous slide, we know that we have a 14% chance of having high blood pressure and a 22% chance of having low blood pressure. Since these percent chances need to add up to 100%, right, we're either categorized as high, normal, or low blood pressure. We know that we will now have a 64% chance, this is a 4, of having normal blood pressure. Now we'd like to use some of the conditional probability information given to us. We were told that of those with an irregular heartbeat, so given that we have an irregular heartbeat, the probability of having high blood pressure is roughly a third. Now, what we want to do is figure out what is the probability of having high blood pressure and an irregular heartbeat. So here we're going to use a product to determine this intersection. We'll take the probability that we have an irregular heartbeat and we'll multiply by the probability of having high blood pressure given that we have an irregular heartbeat. We have both of these pieces of information. We know that this is 0.15, and we know that this is 1/3, and we know that this intersection, the probability of this intersection now is going to simplify to 0.05. So we're going to record this information in the appropriate column and row in the table above. The last piece of information that we're given is that of those with normal blood pressure, 1/8 have an irregular heartbeat. So we have, again, a conditional probability. The given information is that we're dealing with normal blood pressure, and we're looking at the conditional probability that we have an irregular heartbeat given that we have normal blood pressure. We know that this is 1/8. Now, again, we can find our intersection, the probability that we have an irregular heartbeat and normal blood pressure, by using the product formula for our conditional probabilities. So we'd start out by taking the probability that we have a normal blood pressure, and then we would multiply by the conditional probability given that we have normal blood pressure. And the event we're looking at here is, again, having an irregular heartbeat. All right, so we can plug in this information. We know from the table that the probability of N is 0.64, and the probability of having an irregular heartbeat, given that we have normal blood pressure, or the probability of our complement given N, is 1/8, which simplifies down nicely to 0.08. Okay. So now we can record this information as well. We know that 0.08 is the probability that we have normal blood pressure and an irregular heartbeat. Now, believe it or not, this is all the information we need to fill in the rest of the table. So keep in mind that since each one of these is representing one of those intersections, and they're all mutually exclusive, right? So they have no overlap. What we should get is that the entries in a given column should add up to the total percent at the top of that column, or the entries in a given row should add up to the total percent in a given row. So specifically, 0.05 plus something should equal 0.14. So in this case, we know that we can fill in this information with a 0.09. Similarly, 0.05 plus 0.08 should add up to 0.15. So it gets us close, plus that third entry here. So 0.08 and 0.05 gives us 0.13. So we're missing a 0.02 probability for this given column. All right. We can figure out the other two by adding across the row here. Right. 0.08 taken away from 0.64 leaves us with a 0.56 probability, and then 0.02 taken away from 0.22 leaves us with a 0.20 probability. So we're finally in a position to finish this problem. Remember, the original question asks, what portion of the patients have a low blood pressure and, so we're looking at an intersection, a regular heartbeat. So we can look down the regular heartbeat column and look over the low blood pressure row, and we see that 0.20 is going to be our probability. So we have probability of L intersect R. This is equal to 0.2. All right, so this finishes our problem.